Assalamualaikum and good morning everyone. So today I will be present about fundamental principles and application of hydrodynamics in civil engineering. My name is Sharifah Fasha Kistina binti Syed Zainal Abidin. I'm from class DKA 3C. My matrix number is 06 DKA 24F 1068. So I'm going to start with introductions. Hydrodynamics is the study of fluid in motions. It helps us to understand how water flows and how forces acting on it. This is very important in civil engineering because we deal with water supply, drainage, flood control, and irrigation. Let's move on to the fluid properties. So to study fluid, we need to know how its properties. So density is mass per volume. Viscosity is how thick or resistance the fluid is. Pressure is the force per unit area, and velocity is the speed of the flow. These properties are basic but very important for calculation and design. So let's move on to the types of flow. Flow in fluids can be divided into several types. The first one is laminar flow, where particles of fluid move in smooth layer, one over another. This usually happens at low velocity and high viscosity. Like all flowing slowly. So the second is turbulent flow, which is irregular and chaotic with missing of particles. This happens at high velocity, like river rapids. Flow can also be steady, meaning the velocity and condition do not change with time, or unsteady when they change. Knowing the type of flow is important because it affects design, calculation, and safety of civil engineering systems. So to study a flow type, Osborne-Reynolds carried out an experiment. In this test, a glass tube is connected to a water tank and a dye is injected into the flow. If the dye line stays straight, the flow is laminar. If it becomes wavy, it is transitional. And if the dye mixes completely, the flow is turbulent. We can calculate this using the Reynolds number formula. If the Reynolds number is less than 2000, the flow is laminar. Between 2000 and 4000, it is transitional. And more than 4000 means it's turbulent. This experiment is still very useful today in fluid mechanics. Next is continuity equations. The continuity equation is based on the principle of conservation of mass. It says that the amount of fluid entering a system is equal to the amount leaving it. The formula is A1V1 equal to A2V2, where A is the cross-sectional area and V is the velocity. This means when a pipe becomes smaller, the velocity increases so that the flow rate stays the same. For example, water coming out of a nozzle becomes faster because the area is reduced. This equation is very useful in pipe design and water distribution system. Let's move on to the Bernoulli principle. Bernoulli principle explains the conservation of energy in a fluid systems. The formula shows the relationship between pressure, velocity, and elevations. If velocity increases, pressure decreases, and if pressure increases, velocity decreases. This principle can be seen in many real-life examples. For instance, in a venturi meter, the water flows faster in the narrow section and pressure drops. Another example is in airplane wings, where faster air above the wing produces lift. In civil engineering, Bernoulli principle is applied in designing pumps, pipes, and water jets. Real-life applications, hydrodynamics is applied in many civil engineering works. For example, drainage systems are designed to avoid flood. River flow analysis is done to prevent erosion, and pipe networks are designed for water distribution. It is also used in structures like dams and canals. So let's take an example for urban drainage. In big cities, heavy rain can cause flash floods. By applying hydrodynamics principles, engineers can design the right slope and pipe size to move stormwater quickly. This prevents waterlogging and protects the community. So this is my personal reflection. Learning hydrodynamics has given me a better understanding of how water behaves in different conditions. I now realize how important this knowledge is in real projects like drainage and water supply. It also makes me more aware of sustainable water management, such as reducing flood risk and protecting rivers. As a future civil engineering technician, I feel more confident that I can contribute to designing systems that are safe, efficient, and environmentally friendly. In conclusion, hydrodynamics is a key subject in fluid mechanics that explains how fluid moves and behaves. The continuity equation and Bernoulli principles are the main theories that engineers use to study fluid flow. These concepts are applied in drainage systems, river analysis, and pipe networks. Understanding hydrodynamics allows us to design civil engineering systems that are not only safe, but also sustainable for the environment and the community. Thank you very much for your attention. So that's the end of my presentation, and I will be happy to answer any questions.